So by now, we should, if you have watched all of my previous videos, have a pretty decent grasp on binomial expansion, algebraic expansion, and the idea of these binomial relationships I talked about. So our perfect squares and our difference of two squares. And really, the next step here is just consolidating all of this information and attempting questions on mixed expansions. So these are any algebraic expansions that they can involve anything that we've touched on up until now. So before we even try some questions, I want us thinking, well, and as we work through these, we can always have in the back of our head how many terms our expansions will spit out. So you may remember with general expansions or our perfect square, our perfect binomial square expansions, we always ended up with three terms, didn't we? And with our difference of two squares, we always ended up with two terms. So that is something useful to keep in the back of our heads as we work through these questions because we can actually begin to anticipate how our answer is going to look. And we can use this as a type of sense check. So I have an example here, and we'll do one more in a minute. But here I have one type of mixed expansion. And the first thing we're going to do is locate any type of expansions we may have done before. And most of you may see that I have a perfect square expansion. So we have perfect square. And I just have a couple of algebraic terms tacked on at the end here. But we can now work on just doing this perfect square here, just expanding this, because we can tack on the rest of these to whatever answer we get. So how many terms would we expect when we expand our perfect square? Well, we would expect three. And in this form, we'd expect, something with an x squared. We'd expect a whole number. And we'd also expect an x with some coefficient, with some number before it. So that already tells us, well, these two could be like terms with some things we may get when we expand here. So let's just jump straight into it. Now, I'll work through this a little bit quicker because if you're a bit confused and finding it hard to follow, I encourage you to watch the previous videos in the series. But here, this is in the form of a perfect square. So I can square my first term. I can take two lots of the products here. So I'll get 3x plus 3x, which will leave me with 6x. And I'll also get 3 squared, which is 9. And I have my remaining terms of 4x here, minus 7. Cool. So hold on a minute. Like we anticipated, we had some x with a coefficient here, which we can simplify with this one we have. And as well as that, we also had a constant, a whole number, which we can simplify with the other number we were given at the end of our mixed expansion. So taking all of these like terms, our x squared stays the same, and we have positive 6x plus 4x. So we get 10x here. And we also finally have positive 9, and we're going to subtract 7 from that. So we'll end up with 2 here. So that's really the essence of what we're doing. We're just taking the expansions we know, getting everything out, getting everything out, and then simplifying. to our final answer here. Now let's try one more trickier example before we finish up for today. And this one's going to have a lot of elements. So if you're comfortable with this one, I think you're in a pretty good spot in terms of binomial expansion. So here we have, here, I'll give you this example. 4x minus 2 squared. And then from that, we're going to minus x plus 7 and x minus 7. Okay. What do we have here? Once again, we have a perfect square, but we also have here a difference of two squares. Now, I'll actually do this example and one more to lead you up in terms of degrees of difficulty. So this one's a bit of a step up from our previous one, and our final one's going to be another step up from this one. So we have a perfect square here, which we can expand to, well, our first term squared, we're going to get 16x squared. And then two lots of the product of our elements of our binomial, we end up getting negative 8x when we multiply those two, and then multiply by 2 again, we get negative 16x. And then we're going to add this negative 2 squared, which gives us 4. And for the time being, I'm going to put brackets around this just to isolate it from this element here, which I'll also put brackets around, just so we can have them as two separate things, and it'll make the simplification a lot easier. So from that, we're going to minus our difference of two squares here, which we'd expect here two elements to come out when we do our difference of two squares, as opposed to the 3 we get when we expand our perfect square. So taking the first term, squaring it, x squared, and we get a difference of that and the other square, so 7 squared. All right, cool. So we, as we expected, generated 2 terms here, and we generated 3 terms here. So we can already sort of tell how we're going to begin to simplify this. So let's get rid of the brackets now, and we will have 16x squared minus 16x plus 4. And because of this minus in front of the bracket, that gets applied to each of these terms. So minus positive x gives us a negative x squared, I should say. And here we have a double negative. So here it's like saying minus 49. So we will get a positive 49 here. And now we can do our simplification. We have like terms here, as well as here. Okay, so 16x squared minus x squared, we're going to get left with 15x squared. Our negative 16x we can leave because there are no other x's here, so that can stay how it is, minus 16x. And then we're going to add 4 to 49. So we will get left with positive 53. Okay, let's try one more example. And this one will hopefully we'll be able to wrap, like bring everything together. Cool. So example 3, Let's try this one. And this is going to look very overwhelming as I write it down. But as you break it up and identify these relationships that we talked about, these binomial relationships, it becomes a little bit easier. And from that, we're also going to add 5a minus a squared. Okay. Now, don't get overwhelmed. All we have to do is look at the types of binomial relationships we see. Well, here we have our difference of two squares. So that's going to make our life a lot easier because this will all reduce to two terms. And here we have a perfect square, which will give us three terms. But that's okay. At least now we know where we're at. So let's look at doing our difference of two squares first, because in my opinion, that's probably the easiest one we can do. And it's important to note that this a plus 7 is going to multiply by the entire difference of two squares. So I'm going to keep that in brackets, and we will get 4a squared multiplying those two. So the square of the first term is 4a squared. And that's going to be the difference with the other term squared, which will be 81. Now, let's expand our perfect square here and leave that in brackets again. Because honestly, the main struggle I see with students is they try to just rush through this as quickly as they can, and they often end up making mistakes with the signs, so your positives and negatives. It is very easy when dealing with this many algebraic terms. It's very easy to just like lose track of where you're at. So I always leave these brackets in until the very end. For me, that works. If it doesn't for you, if you're cool just going through it, that's sweet. But this for me ensures no little silly errors get made. So we have a perfect square here, which will generate three terms. And we know from the general form we talked about, we'll get the first term squared. So that'll be 25a squared. And we're going to get the product of these two here multiplied by 2. So 5a times negative 8 will get negative 40. Multiplied by 2 will get negative 80a. That's a shocking a. There we go. And we're also going to have our final term squared. So negative 8 squared will give us positive 64. Cool. So you can see where this gets a bit tricky because we're not done yet, right? Because we still have binomial products here. Now, these aren't of any relationship or special type of binomial expansion that we looked at before. This isn't a perfect square. This isn't the difference of two squares. So we will just expand it the old-fashioned way, right? We'll use our FOIL method. So once again, each element of our binomial here will interact with each element here. And I can leave this one as is for the time being. So a multiplied by 4a squared will get 4a cubed. A multiplied by negative 81 will give me negative 81a. Our positive 7 multiplied by our 4a squared will give us positive 28a squared. And 7 multiplied by negative 81 will give us negative 567. Cool. Apologies for all the big numbers. This is why I left the example towards the end. Just as a challenge question, if anyone's had a go at doing it on their own, congratulations, great work. But we're just working through it slowly here. And I can leave my brackets here for the time being. 25a squared minus 80a plus 64. Okay. So now we can write everything without our brackets. Now that we have it all laid out really nicely, we can just apply the positive outside the brackets to our positive and negative terms here. So I'm going to take this, I'm just going to use an extra step just to write this all out again. 81a plus 28a squared minus 567. Now, our positive with another positive, that's going to give us positive 25a squared. Now, this positive outside with our negative 80 will produce a negative. So we get negative 80a and then a positive 64. Cool. Okay. Now, we may have a few extra like terms. So let's just color coordinate these and isolate them. So our negative 81a will combine with this like term of negative 80a. Our 28a squared, a positive 28a squared, will add with our positive 25a squared. And finally, our negative 567 will add with our positive 64. And you may have noticed that our 4a cubed has no like terms, so that can stay. Now, last step, we end up with our 4a cubed and our negative 81a and our negative 80a will give us negative 161a. And our a squared, our positive 28a plus positive 25a will give us positive, sorry, I should say a squared, should give us positive 53a squared. And negative 167 plus 64 will give us negative 503. So this was a huge question, right? And it's okay if you struggled maybe trying it on your own, but in terms of the really hard mixed expansion questions, you really just, really the only place you can go wrong is your signs, or maybe doing a mistake in one of your expansions. But as long as we've combined all of the things we've learned and tackled these things one by one, so you can see in this last question, which was quite difficult, I tackled the difference of two squares first, then I tackled our perfect square first, then I tackled my final binomial expansion. Just do these one by one and take your time with them, because there's a lot that can go wrong. You could hear from me talking as well that occasionally I'd say a when I meant a squared, because there's so many elements here. If you look at this step here, there is so much simplification to do. But if you just take your time and remember all of these binomial relationships we talked about, I think you'll be in a pretty good place. I'll see you guys next time.